All right, imagine this for a second. You're an astronaut. You are floating hundreds of miles above the Earth, looking down at this incredible churning thunderstorm. And then, all of a sudden, a colossal flash of light erupts. But it doesn't go down towards the ground. No, this thing shoots straight up, blasting towards you into the blackness of space. Today, we're diving into what happens when lightning decides to completely break the rules.
I mean, what an image, right? That's how one person who saw it described the sight. It just perfectly captures the awe and, the total mystery of it. It's not just a flash of light, it feels almost alive, like it's connecting our world directly with the cosmos in a way we just never expected.
So let's get into why this is so, electrifying for scientists. An observation like this from way up in space just completely turns our understanding of a simple thunderstorm on its head.
We all learn it as kids. Lightning is this brilliant, powerful bolt of energy that flashes from the clouds down to the earth. It's like a fundamental fact of nature. But this flips the script completely. So it just begs the question, what in the world could be powerful enough to shoot lightning upward, clean out of our atmosphere?
Now, this isn't some meteorological ghost story. This is a real, though incredibly rare, phenomenon. And yep, it has a name that sounds like it's straight out of a sci-fi movie. So let's unmask this upward lightning. And here it is. The official name says it all. A gigantic jet. And they mean gigantic. We're not talking about a little spark. This is a massive column of electrical energy that literally connects our weather systems to the ionosphere. That's the electrically charged layer that really marks the beginning of space. So just how different are we talking? Well, take a look. While your regular everyday lightning goes down, these things go up. Normal lightning hangs out within the first few miles of the atmosphere. Gigantic jets reach a staggering 50 miles high. They are, in pretty much every way, the bigger, rarer, and way more mysterious cousin of the lightning we're all used to.
And to really wrap your head around the mind-boggling scale here, just look at this. Mount Everest, right? The highest point on our entire planet? It's completely dwarfed. The altitude where a 747 cruises? Not even close. A single gigantic jet is an atmospheric event on a truly planetary scale. It's just immense. So how does a storm even begin to muster this kind of incredible power? Well, it takes a perfect storm of conditions, literally. First, you need an unbelievably intense thunderstorm. This creates a huge separation of positive and negative charges. But, and this is the key, something suppresses the normal downward lightning strikes. This allows a massive amount of charge to build up at the very top of the cloud. When that charge finally breaks free, the path of least resistance isn't down, it's up, straight up. You see, capturing this from the International Space Station has been a massive breakthrough. For decades, these jets were just these fleeting mysteries, things pilots would glimpse and wonder about. Seeing them from above, it changes everything.
Think about it. From the ground, you're trying to look up through miles and miles of turbulent, cloudy atmosphere. Good luck with that. But from the ISS, you've got a perfect, unobstructed, top-down view. Astronauts and instruments can watch the entire event unfold, measure its energy, and spot them happening over remote oceans where absolutely no one else is watching. It's the ultimate scientific high ground.
And just think about that number again. 50 miles. At that altitude, this isn't just a weather event anymore, no way. It's a direct physical link between the troposphere, that's where all our weather happens, and the ionosphere, a region we usually associate with satellites and the aurora. This jet is literally bridging two completely different realms of our planet.
Now, this might seem like a really niche, kind of bizarre weather phenomenon, but scientists believe these jets are actually a critical piece of a much larger planetary puzzle. So why do these incredible flashes of light really matter?
Okay, try to picture our entire planet as having this giant, invisible electrical circuit. There's a constant current flowing between the ground and the ionosphere. Thunderstorms? They act like the batteries powering this whole global circuit, constantly recharging it. Gigantic jets, then, are like these massive, dramatic pathways in that system, moving huge amounts of charge in a way we're really only just beginning to understand. So studying them helps us figure out how Earth balances its entire electrical budget. By shooting all those charged particles so high up, these jets could actually be altering the chemistry of our upper atmosphere. And yeah, an electrical blast this massive, this close to space, it could even have implications for some of our low-orbiting satellites and other tech. So when you boil it all down, these things are way more than just atmospheric curiosities. Gigantic jets are a fundamental force of nature, a powerful, visible connection, proving that our planet's systems, from the ground beneath our feet to the very edge of space, are all intricately, beautifully linked together.
The discovery and study of gigantic jets just reminds us that, even now, our planet still holds these profound mysteries. It really makes you wonder, doesn't it? As we keep watching from new vantage points like space, what other incredible secrets are hidden up there in plain sight, just waiting for us to look up?